It wasn't that long ago we were all perfectly fine with the daily ritual of digging behind our nightstands, wrestling with a messy bird's nest of charging cables. But today, we just casually drop our phones onto a sleek little pad, hear that satisfying ding, and walk away. It is literally that seamless. And because it's so completely effortless, it really begs the question, are wires truly extinct now? Is this just magic? Think about it. How exactly is a solid battery locked inside a sealed glass and metal rectangle magically filling up with power just by resting on a table? It feels like a straight-up magic trick from some sci-fi future. But the reality? Well, it's actually much more grounded and honestly a lot more fascinating than magic. All right, let's dive right into this. The big secret behind your futuristic charging pad is actually a super clever application of a 19th century physics principle. It's called electromagnetic induction. Basically, this is the process where moving a magnetic field through a wire actually creates electricity. So instead of power flowing through a physical metal cable directly into your phone's port, the electricity is converted into a magnetic field, passed invisibly through the air, and then converted right back into electricity once it's safely inside your phone. How cool is that? Section 1. Meet the coils. Time to pull back the curtain. Now, to make electricity literally jump through thin air, we need two main characters. First up, the transmitter coil. This guy lives inside your charging pad, and its whole job is to send the energy out. Second, we've got the receiver coil, which is built right into the back of your smartphone. Its job is to catch that energy. And if you're wondering what these coils actually look like, they aren't some hyper-complex microchips. They are literally just tightly wound spirals of standard copper wire. These two copper spirals are the absolute foundation of the whole shebang. Section 2, the four-step process. Let's trace the journey of the spark. So, there are 4 specific phases to this journey. We start by creating an alternating current. Then we generate a magnetic field from that current. We catch that field inside the phone. And finally, we convert it all back to power the battery. Let's walk step by step through exactly how this happens, starting right at the wall outlet. Step 1 kicks off the moment you plug your charging pad into the wall. Electricity flows into the pad, but here's the catch. Standard electrical current straight from your wall just isn't ready for wireless transmission yet. It needs a serious makeover. So a tiny circuit board inside the pad takes that incoming electricity and converts it into a high-frequency alternating current, or AC. In plain English, the electricity isn't just flowing smoothly in one direction anymore. It's rapidly vibrating back and forth inside the pad. Now, the absolutely crucial point here is what happens next in step 2. That highly vibrating alternating current rushes through the pad's copper transmitter coil. And thanks to a fundamental rule of physics called Ampere's law, moving electricity creates a magnetic field. But remember, our current is alternating, right? It's constantly changing direction. Because of that, it creates a dynamic, fluctuating magnetic field. Picture invisible, glowing ripples spreading upward and outward from the charging pad, kind of like waves expanding on the surface of a pond after you drop a pebble in. All right, step 3 is the handoff. This is the exact moment you set your phone down onto the pad. When you do, the receiver coil inside your phone is sitting perfectly inside those fluctuating magnetic ripples we just talked about. As those expanding and collapsing magnetic field lines pass completely through the phone's copper coil, they physically force the electrons inside that wire to start bouncing around. This right here? This is Faraday's law of induction in action. A changing magnetic field inside a loop of wire induces an electrical current. The magnetism has successfully morphed back into electricity. Finally, we hit step 4. The current that was just generated inside your phone's coil is still that wild, rapidly vibrating alternating current. But here's the thing, your smartphone battery is incredibly picky. It can only eat and store smooth direct current, or DC. So, the phone's internal circuits route this vibrating power through a tiny little component called a rectifier. The rectifier instantly smooths the power out, converting it back into a stable one-way flow of direct current and safely funnels it straight into your battery. Boom, your phone is charging. Let's move to section 3, the alignment problem. Because, yeah, there is a catch. It really all comes down to the nature of magnetic fields. Standard inductive charging requires what physicists call tight magnetic coupling. See, those magnetic ripples generated by the pad are highly localized. They don't travel very far, and their strength drops off incredibly fast with literally just a millimeter of distance. So if those two copper spirals, the one in the pad and the one in the phone, aren't lined up absolutely perfectly, The magnetic waves just shoot up into empty air and miss the target receiver coil entirely. No alignment means no induced current, and your battery stays totally flat. But what's really interesting here is how modern engineering has completely stepped in to solve this physics limitation. While standard inductive charging relies on you just kind of guessing where the center of the pad is, which, let's be real, fails half the time, newer tech like Apple's MagSafe or the universal Q2 standard completely changes the game. They solve this by adding a literal ring of physical magnets right around the outside of the coils. When you bring the phone close, those magnets snap together with that incredibly satisfying click. It physically forces the transmitter and receiver coils into absolute perfect alignment every single time. It completely removes the guesswork, ensuring zero energy is wasted shooting into thin air.
Section 4, the heat myth. Let's give you some reassurance.
So the truth here is a bit nuanced. You've probably heard rumors that wireless charging ruins your battery. Well, the real culprit behind that rumor is heat. It is true that wireless charging generates more ambient heat than using a traditional wired cable. That's simply because converting electricity into a magnetic field and then back again just isn't 100% efficient. Some of that energy gets lost in the transfer and escapes as heat. But here's the reassurance. You really don't need to worry about cooking your battery, because your devices are incredibly smart. Your phone and the charging pad are actually talking to each other the entire time, using tiny low-power radio signals. If your phone's internal sensors detect things are getting even a fraction of a degree too warm, it immediately tells the pad to throttle down the power, or it just shuts the whole process off entirely until the device cools back down to a safe green zone. Your phone completely protects itself. Which brings us to our final thought. What looks and feels like everyday magic is really just brilliant modern engineering layered right on top of century-old physics to make our daily lives a little cleaner and a lot less tangled. As we keep perfecting these magnetic fields and making them even more efficient, are we truly ready for a completely wireless future? Could we actually see a day when charging ports vanish from our devices entirely? It's a pretty fascinating thought to carry with you the next time you effortlessly drop your phone onto that pad. Thanks for joining me on this explainer, and keep questioning how the everyday magic around you really works.